and this is my Physics 2211 Lab 1 on the momentum principle. In this lab, we will apply Newton's fundamental laws of physics. We use the momentum principle, also known as Newton's second law of physics, to compare the results of an object in motion with constant velocity in the real world to one done in a computational model. Newton's second law says that an object in motion will stay in motion unless acted on by an outside force. In ideal conditions, an object will continue with its velocity in a straight line forever. This also means that an object with zero net force acting on it will have no acceleration or deceleration. In this lab, there are some important calculations that we should know. We have the velocity update formula, which is final velocity equals initial velocity plus net force divided by mass times delta t. We have the position update formula, which is final position equals initial position plus average velocity times delta t. And we have our initial velocity calculations seen down below, which came from our experiment. Now we go into Tracker to see our real-world experiment. When we play the video, we see the ball move frame by frame, and the outputted position versus time graph is shown on the right. You can also see the conditions of where we set our origin and the direction of the positive and negative axes. Alright, so now we go into GlowScript. The first thing that we edit is the radius of our object, which is seen as 0.073 meters. We also add the mass of our ball, which is 0.02211 kilograms, and then update the initial position and the initial velocity of the ball. The next thing we do is that we change the while loop to when t is less than 0.5 seconds, because that's when our time experiment ends. Then you see here we implement the velocity update formula and the position update formula. And now that we have that, we can run the program. And we can see that the ball moves in a straight line, and this is shown with the position versus time graph moving very linear. Alright, so now we jump into Logger Pro. On the left hand side, we have the data of our experimental and computational models. And as we can see, the lines are both very similar and they are linear, with the experimental value having a smaller slope than the computational model. Alright, so now it's time for our results. When the object was given an initial velocity and there were no outside forces, the velocity stayed constant. The velocity in the computational model was higher than the experimental model. The deviation of the line of best fit for experimental was 0.00239, and for the computational model was 0. The R-squared values have very minimal difference, with the computational being 1 and the experimental being 0.999. The object did not move in a straight line perfectly, leading to different experimental and predicted values. Now what if I were to flip my x-axis? I set the positive x direction going towards the right, making my velocities positive. If I were to flip the x-coordinates, I would have velocities with the same magnitude, however they would have different directions and be negative. Now are we able to tell how many pushes and pulls there are? Unfortunately we can't, since the net force is 0. All we know is that the velocity is constant because the net force acting on the object is 0. Alright, so that's it for my project.